Hi everyone, my name is Gabriel, and as part of this week's presentation, today I will be discussing about the sensor networks for tracking UV sun exposure. From low-tech to high-tech, several companies are competing to bring consumers better information about exposure to the sun's ultraviolet rays. Some of these products that are already in the market are Climate, Sunsprint, Violet, UVA plus V Sunfriend, June, and most likely the new updates to the recently released Samsung Gear S2 G3. In general, these emerging products help consumers balance the need to travel around outdoors while covering up and avoiding excessive sun exposure given their skin type, geographic location, season, weather conditions, and whether they're wearing sunscreen. But let's see what Silicon Labs can offer to anyone who wants to incorporate the SI1147 sensor into new products. Well, the first component needed will be a sensor pack board, which is a demonstration and evaluation product for sensor products with an EFM32 MCU. It has a relative humidity and temperature sensor on it. It also has an optical sensor to do ambient light, ultraviolet, and heart rate measurements. But why will a maker use this? Well, this sensor pack board also has a G-type head added to it, so it can be reprogrammed. For this, we will need two additional pieces of hardware. First, a standard 9P ARM Cortex debug cable, and secondly, an EFM32 development kit with a 20-pin debug out header, such as the Zero Geeko SDK. And all of the software is available in Simplicity Studio, which allows you to view and modify the firmware source code. So let's see how everything works. About the key technical features of the sensor pack board, the evaluation kit consists of an on and off switch in the off position. When the switch is turned on, the pack will automatically start taking and broadcasting data. Here is when the SI1147 optical sensor and SI7021 relative humidity and temperature sensor start to work. This sensor pack board runs from internal memory on the energy-friendly Gecko microcontroller EFM32. For the pack itself, there is no installation required. The data that is broadcasted it is displayed on a mobile device through the use of a Bluetooth Low Energy module. And yes, it does broadcast data to iOS and Android smartphones with a downloadable Silicon Labs app. And for the power management, the board features a Touchstone TS3310 Boost DC-DC converter, in which all key components have industry-leading low power consumption. Finally, let's not forget that this sensor pack board can be reprogrammed. So, in general, to use the optical sensor SI1147 that measures UV indexes, it will need to be firstly tested using a sensor pack board, which broadcasts the data using a Bluetooth Low Energy module to iOS or Android mobile devices. And if needed, this sensor pack board can be reprogrammed using the EFM32 SDK MCU in combination with the Simplicity Software Studio that allows to view and modify the firmware source code using C or C++. Then, once the sensor has been reprogrammed, it can start broadcasting again, and the change will be visible using the Silicon Labs application that is available for iOS and Android smartphones. As we said before, the data from the sensor pack board is broadcasted over a Bluetooth Low Energy, and to understand the difference between the BLE and the Bluetooth Classic, let's see this comparison table. To start, we can see that the Bluetooth Classic surpasses the BLE capabilities in terms of security, data transfer range, and range. However, the BLE shows a better performance in terms of considerably reduced power consumption, the speed of connection, size, and cost, aspects that have made this protocol very special for novel applications. So, as we have seen along this video, the sensor pack board can be used outdoors or in a conference room without the need for a PC connection. No need to develop biometric sensor drivers from scratch, just modify the configuration for your platform. By using broadcast mode, a connection does not need to be established, enabling quick and easy display of sensor data from multiple packs, which in turn demonstrate advantage for battery-powered applications. If there are several sensor packs, you can use the navigation drawer to select a different pack. The development of the optical sensor and the board that may contain it can be in terms of better batteries that last longer, miniaturization of components, enhancement of the accuracy of the measurements. Finally, the recent developments in the application of sensors might include multifunctionality. I have included some reference in case someone might be interested in a particular topic discussed. Thank you for watching this video.